So far we've spent some time graphing. So we were able to, here's a graph, and then, so there's my answer right there. There's my equation, there's where the cross, so there's my answer. We've also spent some time where we solve for y, and then we plug that into the other equation, like so, and then we solved for x and y in that way. So we've done number one, graphing. Number two, we've spent time doing what was called substitution. And now we're going to look at the last method. And this method is called elimination. So we're going to solve by elimination. It has another name too, depending on your school of thought. Sometimes it's called linear combination. Why? Because we combine two linear equations. Why do we do that? In order to eliminate something. In order to eliminate a variable. So both of these are synonymous. Linear combination means that's the process. Elimination is my goal. But they're both names for this process. All right. Since you are currently living in Massachusetts, we figured, heck, maybe if we can put the steps in mass form, it'll be a little bit easier to follow. So these are the steps right here. And all right, so let's see here. First, we're going to multiply equations to get opposite coefficients. We'll explain that as we go. We're going to add the equations together. We just stack them and cancel stuff out. Next, we're going to solve for one of the variables. We're going to substitute that value into any equation, solve for the other variable. And lastly, we check. Just to give you a heads up, these last three steps are exactly the same as the previous. There's no difference. Once you have a value, so for example, once we have x equals 3, we shove that into the other equation and solve. So this last part is going to be very familiar. Okay, so first off, what do we mean by opposite coefficients? Because that's the key in this process, to get opposite coefficients. Well, for example, if I have 3x, then opposite is this, negative 3x. Or if I have y, then the opposite is negative y. So we need to make sure that we have opposite coefficients in order for this process to work. All right, so let's walk through here. This first one actually is nice because it already gives us opposite coefficients. Notice right here, I have positive 3x right there and a negative 3x right there. So here's my system. Notice that the forms are the same. So we might actually want to put a step 0 on this. A step 0, we need to make sure that these are in the same form. Now, it never actually matters what form they're in, as long as they're the same. The key is we just need to line them up and subtract them. Now, watch this. Remember, same thing here. If I have 31.72, and we were going back old school, and I wanted to add 1.2 to that. Well, maybe you would have lined it up like this and said, oh, okay, 1.2. Yay, now I can add those together or subtract those. Is that right or is that wrong? Quick conversation. So the key thing here is we need, it's an ugly 7. So the decimals need to line up. So it should actually look like this, 31.72, and then the 1.2, and we could put that ghost 0 there if we wanted, but you don't have to. And now it's lined up. So what's the key here? The forms are the same. They have decimals. So I'm not doing a fraction in a decimal. So they have the same form. And I line them up. And what's the key thing is the decimal. Well, over here, the key thing on an equation is the equal sign. So I make sure they have the same form, and I line them up using the equal. All right, so I multiply anything to get opposite coefficients, and notice I don't have to do that. I already have opposite here. So I'm going to rewrite, although in future you would not do this. I'm just doing this as a just to show the flow there. But we need to combine these two like so. So all we do is draw that line. And notice what step number 2 is. We're going to add the equations together. So add them just like I would the tens place, etc. All right, so I've made that change. Now, let's just add these together. So when we add these together, this is what we get. So notice that 3x minus 3x is 0. Yay! Don't even pay attention to it, just cross it out. Now I add, in other words, I combine my like terms here. Now I have 2y plus 4y is 6y. And then on the other side, I bring down the equal, and 7 plus 5 is 12. Notice this, no substituting, no solving for a variable. All we did was combine them. We combined the linear equations, and now we eliminate and solve. What did I do? I divided both by 6. So I solved for that variable. And now this part should look very familiar. All we're going to do is take this 2 and substitute it either here or here, and it doesn't matter where. Just choose one to do. I'm going to choose the top just because it looks like it has fewer fractions or negatives. So 3x plus 2 times 2 equals 7. And let me just make sure that's a 2. Yep. All right. And 3x plus 4 equals 7. 3x equals 3, and x equals 1. All right, so I'm claiming that my solution is 1, 2. So let me put that down as my answer, 1, 2, as parentheses. Remember, this is one way to write the answer. I could have said this just as a list. Bring it all together, though. So please don't leave it separate all over your page and just circle over here and then circle over here. That makes it for a lot of unnecessary looking. Just up near where the original problem was, circle one of those two options as a point or as a list. Now, of course, the last step here is to check. So I'll just walk through a mental check real quick. 3 times 1 is 3. Plus 2 times 2 is 4, so 3 plus 4 is 7. Yay, that works. Now, this gives me a negative 3, this gives me an 8, so 8 minus 3 gives me a 5, so it does work. Since we're not using the arrows, the way to start this one out is simply to notice, oh, look, I already have opposite coefficients. So just go ahead and draw your line right now. Now, all right, so sometimes it's set up for us nice and pretty, but guess what? Life is not always that nice to us. So notice what we have here. We do not have it set up for us. So I don't have opposite coefficients here or here. So I have to think to myself, how do I make these the same but opposite, or these the same? And it doesn't matter which one I choose, as long as I choose one of them. Go ahead. All right, so I do notice that if I can make this 2 right here into a 4, I have opposites. Great. So here's the magic that I'm going to do. I'm going to take this and multiply the entire beast by 2. Everywhere, all across the board. So this is what I get when I do that. 2x minus 6y equals 8. And now notice the bottom equation. Oops, I did make a mistake. Thanks. This is a 4. So I forgot to distribute. So 4x minus 6y equals 8. And now I'm going to bring down or bring over, with no change, the bottom equation. So step number 1. I multiplied both equations in order to get opposite, I multiplied to get opposite coefficients. In this case, only one equation. Now I have opposite coefficients, so step number 2 says I'm just going to add them together. Now, coincidentally, on the examples that we've been doing, so far we've been canceling out the x's, but that doesn't have to be the case. It can be either letter, as long as you're just dropping them out. So I notice here that the x's drop out, and so I bring down the negative y equals 0. When I take the opposite, I get y equals 0, no change. So step number 1, I multiplied. Step number 2, I added. Step number 3, I solved. M-A-S. Now the last one, before I check, I need to substitute that in and finish up. So substitute this 0. It can go in either equation. I'll put it on the top. And so step number 4 here looks like this. 2x minus 3 times 0 equals 4. 2x equals 4 and x equals 2. So I'm claiming that my solution is 2, 0. And now let's walk through the check, and I'm just going to do a mental check for now to speed up the process. Yeah, so in this case we have a conundrum. What do I multiply the top by to make it look like the bottom? Or what do I multiply the bottom by to look like the top? Well, notice here, instead of saying or, I'm actually going to say and. I'm going to have to multiply both of these to get opposite coefficients. So notice, how do I do that? Well, there's actually multiple different ways, but if I want to kill the a, all you do is take this 2, multiply it down, and take this 3 and multiply it up, and then make sure one of them is opposite. If I want to kill the z's, I just do the same there as well. Okay, effectively what we're doing is doing common multiples. So let's figure out what we do. I'm just going to do the a because it's up in the front. So I'm going to take this 3 and multiply it across the board there. Now I'm going to take this 2 here and multiply it across the board there. However, let's just pay attention. What do I need? This will give me a positive 6a. This will give me a positive 6a. But I want one of them to be opposite. So I'm just going to change this to negative. And it doesn't matter which one. So let me go ahead and multiply out. So 6a plus 18z will give me 12. Down below, negative 6a plus 14z will give me a negative 12. So step number 1, I multiplied out to get opposite coefficients. Step number 2, I'm doing the adding. Now notice the 6a's drop out, so I'm left here with 32z equals 0. So z equals 0, and that's my step 3. Solve for a variable. Now step 4, I'm going to substitute that into wherever I want. I'll place. So I'm going to substitute right here into the first equation. So 2a minus 6 times 0 equals 4. 2a, the 6 drops out, equals 4. And so a is going to give me a 2. So I'm claiming that my answer is 2, 0. So a equals 2 and z equals 0. Notice I'm not putting it as a point only because the letters aren't x and y, and also it might be a little bit easier to read that way. So now we're just going to do a double check real quick and make sure it works. And then when we substitute and do the check here, 4 plus 4 equals 0, 4 equals 4, ka-chow, check. And over here, 6 does indeed equal 6. So it does work out. Yay, us. So now please go to the next problem here and practice that. The hint I will give you here is that we do need to multiply both. So I suggest we can multiply the top by 4 and the bottom by 6. Why? Because that'll give me a 24 here and a negative 24 here.